Here's an example of a Newton's law of motion problem that we're going to have to solve using free body diagrams. So we have someone pushing a lawnmower at a constant speed, and constant speed is important because that means that F net is equal to 0. And remember that these questions are a little bit easier to do when you have no net force. The lawnmower is being pushed with a force of 100 newtons at an angle 55 degrees to the horizontal. We're going to look for the normal force and the force of friction. So let's start off by drawing a free body diagram. So we have our mass here of our lawnmower, and that's going to be 20 kilograms. Next up, we actually need to draw the free body diagram for the lawnmower. So if we have our lawnmower represented by this rectangle right here, it's on the ground. So it's on the surface, and we know we have our FG. We have an equal but opposite Fn. We then have some sort of force of friction. And we know we have our applied force, which is happening at an angle 55 degrees to the horizontal. So if I just draw a horizontal plane here, actually I'm going to take that back just a little bit because it should be the same length as our force of friction. Then I can draw my FA. So that's my applied force. And that applied force has that horizontal component and, of course, a vertical component. So we're going to be able to deal with those to solve this problem. So we know a couple of things which make it very easy, or at least helpful, to solve here. So we know that constant speed means F net equals 0. So the sum of all the forces in the y and in the x directions are also going to be 0. Let's start out by looking for the normal force. So Fn is in the y plane. So that means we're going to have to start off by saying that the sum of all the forces in the y direction are equal to 0. And then let's figure out what all those forces are. So 0 is equal to, of course, we have the normal force. Okay. And now our force of gravity is opposite. So we're going to say positive, and to the right, or north and east, are going to be positive, and then like south and west, or down and to the left, are going to be negative. So our normal force is positive. Our Fg, force of gravity, is going to be a negative value. And we have the y component of our applied force, which is Fa sine theta, which is also going to be negative because it's going against our positive direction. So just remember that up, we'll say that up and to the right are going to be positive. So we can then plug in what we know and then leave out what we don't know. So if I rearrange this a little bit, I have Fn on one side, and that gives me Fg plus Fa sine theta. So Fg is equal to the mass times the force of gravity. Fa is equal to 100 newtons times sine theta, which is sine 55. I can start plugging in a little bit more, so I know my mass is 20. Make sure that it's in kilograms. Our force of gravity, or our value for G here, is going to be 9.8 newtons per kilogram, plus 10, or plus 100 sine 55. I can solve all of that, and I'm left with 278 newtons, and that's going to be in the up direction. I can do a very similar but slightly easier, because there's less values, calculation for um, the force of friction. So if I have the sum of all my forces in the x direction equal to 0, that means 0 is equal to, we have Fa cos theta, so that's the x component of my applied force, minus the force of friction, because it's going the opposite direction. So when I rearrange, I get my force of friction is equal to Fa, which is 100, times cos theta, which is 55, which leaves me with the force of friction of 57.4 newtons. Looking at my equation, or my diagram, sorry, that's going in the backwards direction. So Fn, 290 or 278 newtons up, Ff, 57.4 newtons back.